Hi guys, my name is Pranam Marjara and today we will be demonstrating ARCxSPEECH. So as you can see, this is our dashboard and it has loaded up beautifully, and we see three options, which is open clinical assessment, open clinical history or open R&D mode. These all modes are made for the best prototyping and the best test run capabilities, because this is a very novel thing in India, and in order to accomplish better clinical goals, we have to just focus on reinforcement, reinforcement, and reinforcement. So let's try our clinical assessment. So we will click this, and then we need to fill in the patient name, the patient ID, the patient age, and the patient's gender. Then we will click on start assignment, and now as you can see that we have two tests here. One is record sustained vowel, which is for 3 times and for a duration of 5 seconds, and then we have record DDK repetitions 3 times and which has a duration of 10 seconds, and these also has to be done 3 times. So the thing is that in order to have the best accuracy, we have to record a certain voice input 3 times, and then we average out its metrics in order to give the final score. So now, in order to record it, what's the biggest problem? The biggest problem is that every single mic out there records audio in a very different way. It's not that humanly possible that every single mic will give us an audio output that every single computer will register as the same. So in order to do that, we have to standardize the mic. Now this will be given to the patient to be mounted on the top of their head with a headband, and that will have a boom mic with it. That device, that part of the prototype is currently under 3D printing, but right now what I have is the main part. So here we have an INP mic module, and with that we have Zhao ESP32 S3, and that is connected via a USB-C cable to my laptop. So let's plug it in. So this will be working as a standardized mic, so every single one of the clinics out there will have this mic of ours. And now as we can see that this mic is plug and play, so let's start recording voice. So first we will be proceeding with the sustain vowel for 3 times. So let's start. Okay, once done. Now let's complete the rest of them. Okay, not very good at this. Okay, so let's go out with the DDK repetitions. Pataka, 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 pataka. Pataka, 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 pataka. Okay, so all the recordings are done, and this mic has beautifully worked, which it really does in the prototyping phase. So now let's process the assessment, and it will take some time. It will take all the recordings, it will average out, and then it will be based on some research papers. Yeah, here we go. So as we can see that the assessment information is being provided now. So here's the patient ID and age, gender, and assessment date, because the names are not being recorded for privacy reasons. Yeah, so as we can see, the sustained vowel has different metrics assigned to it. For example, the ZCR mean, the spectral centroid, the HNR resonance, the jitter locals, and the same has been done with the DDK repetitions. So what we will be doing is that based on these metrics, we will be further having longitudinal tracking of the patient. So this has to be done, like, I guess, how many times? In order to make it feasible, we have to at least run it every single week on the patient for a span of like 3 months to get really feasible and really clinically accurate data about the patient. And then what we can do is that based on these repeated assessments, we will be plotting a line graph for the clinicians to see, so they can actually see if the arc of the patient is going up or it's going down or it's staying around the same constant. So this was the test run of our app, and if we check in the clinical history, we can see that our clinical assessment has just been recorded. And in order to view this, we can just click on it, we can view assessment, and we have all of our metrics that we recorded, every single one of them, every single one of the recordings. So the clinician or the person using it has complete authority over it, and they can check that even if for example audio signal comes off because the mic might not be connected properly or something happens, it will show that there is a problem with the recording, so it will pinpoint the exact recording. And if we go on the R&D mode, this is something to be done with the prototyping. So all in all, this was this ARCxSPEECH dashboard, and this will be connected via a boom that will come right from the patient's head. It will be a variable and it will be around this distance, and we calculated the distance based on the best clinical medical speech approach which is going on right now and which is well tested. So that's why I was holding it right here. So this was a clinical assessment, and this is ARC. Thank you.